Good morning. This is Ian McCluskey at OutBack Power. I am waiting for some more folks to join on. We had a pretty good number of signups, so watch the attendees come in here. Want to make sure, can everybody hear me all right? Is there any concerns with the audio quality? Thank you. All right, we got a confirmation there in the questions. Cool. So I won't make the folks that joined on time wait too long before I get started with the presentation, but just another 60 seconds or so. And this is a relatively short slideshow, only about 15 slides, and some of them maybe material that you're familiar with if you've installed a charge controller before, which is a good time for me to start this poll. Let's see. So let's see who on the call has installed a current generation or a former generation. Oh, whoops. I did not mean to close that. Double tapped. Oops. Accidentally hit close. Well, I wanted to find out how many folks on the call have installed an FM100. But let me see here. Maybe it'll let me restart that. Oh, that's going to be a pain. Okay. Well, then we'll jump into the second poll. So before I get started, how many folks on the call have installed a new FM100 AFCI? This is the new FLEXmax. The part number is FM100-300VDC-AFCI, and it's basically the same or very similar product. We made some other updates, but the main addition here is the arc fault detection built in. So please respond if you've installed a new FLEXmax 100 AFCI yet. And to be clear, this product has not been fully announced to the market yet. We've started shipping units over the summer for specific beta sites and field trials and such. So I want to see how many folks on the call have hands-on experience with the product. And we do plan on releasing this product fully to sales on December 9th. So it's already in production. It's going very well. And on December 9th will be the official announcement for general availability. All right, so it looks like, as I was expecting, most of the folks on here have not installed one yet, but hopefully that will change soon. These are making their way, into the inventories across the country to be installed in North America, Latin America, the Caribbean, Europe, and Australia is mostly where they have been shipped so far. So we'll get started now. I think we have a good percentage of folks that have signed up or joined, so we'll go ahead and jump in. So FLEXmax 100 with AFCI. Now this topic is, we've spoken about this product in regards to the NEC 2017 and what the changes mean for code compliance, how this makes complying with module level rapid shutdown and other NEC 2017 requirements much easier than with our previous charge controllers, such as the FM60 and the FM80, and even the current FM100. There are a lot of challenges to complying with NEC 2017 with those charge controllers, and frankly, with charge controllers in general. The code NEC 2017 does not make life easier for charge controllers. So we recognize that building an arc fault was absolutely necessary. And this presentation is, we're going to focus on the wiring changes or the differences between typical OutBack charge controller wiring that you're used to and how to wire the PV and batteries. Really, the main changes to PV, as we'll see, but how to wire the system with this new arc fault version. So here's a photo of the unit. It has the same plastic enclosure as the current generation. and the content. So we'll quickly go over the product itself for folks that aren't familiar with it or would like a refresher, and then we'll look at the wiring changes, and at the end we'll talk about integrated system options and how those wiring changes are going to roll into the FLEXpower and GS load centers, the GSLCs, that we'll be releasing next month. So let's get started. Feature summary. Latest integrations to maximize return on investment. Of course, there are 300-volt load centers, FLEXpowers, and system edge packages, all popular products and growing segments of our growing product segments for OutBack. You know, I think the more turnkey the solution, the better these days. You know, I know installer time is a huge constraint, right? There's always more work than time to do it. So we want to make sure our solutions are fast and easy to install as possible. We simplified NEC 2017 on that note, module level rapid shutdown. And so the system edge packages actually come with the Fire Raptor module level rapid shutdown solutions, which have really helped make compliance a lot more straightforward. Engineered for reliability. This has a 5-year warranty. We put both generations through highly accelerated life cycle testing. It has a NEMA 3R enclosure, IP54 ingress rating, so that means it can be installed outdoors. And one thing to speak to that outdoor rating is in Canada, for example, now that the arc fault is built in, it's possible to use this charge controller in you know, very low temperature installations, where in the past the exterior arc fault solution in the combiner box out at the array did not comply because those arc fault solutions typically aren't rated for, you know, -20 or -40 degrees Celsius. But now that it's built into the charge controller, all the combiner box doesn't require any, you know, sensitive electronics. So this product now works well in freezing environments like that. Of course, it meets the NEC 2014 and NEC 2017 requirements, the latest AFCI requirements, ground fault and rapid shutdown. And we updated the algorithm. Just one question I get a lot, and I recently got a good answer on it. The sweep rate is dynamic. So the sweep rate increases the higher the power, and hopefully folks were able to see my screen there. I realized I left the poll open, but and here's a quick share of that poll. So yeah, we only had about 1 out of 10 folks on this call have been able to install them yet, but hopefully that will change soon. Moving forward, the sweep rate increases at higher power from the array, and it decreases at lower power. So if the power is changing, the sweep rate is faster, and if it's not changing, the sweep rate dynamically slows down. And the maximum efficiency of this charge controller is right around 200 to 250 volts. So it's right in that sweet spot of where, you know, a typical array is going to be if it's sized appropriately. Those are questions that come up oftentimes when I talk about the MPPT algorithm. Yeah, sorry guys. Sorry about leaving that poll up. I didn't realize it was just blocking the screen, but we'll keep going here. So we didn't miss much. There was nothing. No material there. Just these 4 bullet points. So now we're getting into the good stuff here. New arc fault detection listed UL 1699B. That's the arc fault standard. Max input of 7,000 watts. So we warranty up to 7,000 watts of PV input now. With up to 6,000 watts of charging. That's basically 100 amps at 60 volts on a 48-volt battery bank. So that's, you know, depends on your battery charging voltage, but it can do 100 amps at whatever voltage you want, basically. Enhanced MPPT algorithm for increased energy harvest, especially in harsh environments like the freezing environments I mentioned earlier. It's rated for a maximum PV of 300 VDC. active cooling outdoor rated, built-in ground fault protection. That was on the previous generation as well. The field upgradable firmware is a nice feature addition compared to the FM60 and the FM80, which had to be sent in to get their firmware upgraded. So now that you can update in the field, as we improve the firmware for the product, we'll be able to send out that firmware remotely, downloadable on the internet. And compared to the previous generation for NEC 2017 systems, we estimate, upwards of $1,000 per charge controller in savings, because you won't need that external, $1,000 plus external combiner box that goes on the roof. Here are the specifications. We'll let you just give a moment here to look over these. I won't read them out one by one. If anybody has any questions, feel free to chime in. This is a new slide. This is I think it's a good illustration of the benefit of a properly matched input and output rating, right? The FM100 accepts up to 7,000 watts PV, and it can charge at 100 amps. Whereas there are some other charge controllers on the market that can accept, higher voltages or large arrays, but they are limited at their charging output. And so, you see in a given day, this is in the Los Angeles simulation, your output over the course of the day is going to max out. It's going to clip, on the lower output in charge controllers, whereas the FM100 will be able to put out much more over the course of the year. I think this adds up to over a megawatt hour actually over the course of a year, just for a single charge controller, which can be a huge, cost difference for a customer. So this is over the course of a day, right? You can see the stacked bar here. The cumulative output in kilowatt hours is almost, it looks like it's about 500 kilowatt hours just in a single sunny day, which when you over the course of a year makes up pretty significant difference. So we have a couple questions rolling in. I'll answer these as we go. No 12 volts. Yes, we do not support 12 volt on this product. It's much larger than would be. When we did the market research, it didn't seem necessary for a charge controller this size. There are a lot of really low cost, small charge controllers on the market that serve the 12 volt market. And I don't know if it goes all the way back to the extreme, but it does go back to the previous generation. The current and the next generation charge controllers are both 24, 36, and 48 only. Another question is, can I use it for outdoor installation in the Middle East? Yes, absolutely. It has active cooling, which will help. And those NEMA ratings are appropriate for dusty environments, sandy environments, wet environments. They're not appropriate for like submersion or anything like that. But for wet, rain, sand, dust, it's a sealed enclosure, so it will protect the products from those sorts of conditions. One last look at this slide, but I think it's an important one to keep in mind. All right, now we're at the wiring changes, which is what I think everybody came for today. So here's a quick diagram of an NEC 2017 compliant system with your Fire Raptor devices on the roof, one on each module. You have we'll go through this piece by piece, right? So your ground fault, arc fault, and rapid shutdown are all built into the charge controller. The brains of the charge controller can handle all three of those functions. D is the optional rapid shutdown to inverter. And this is an important one, I think, that, the rapid shutdown requirements specify the roof, but firefighters actually don't go through the roof typically. They usually go through walls, and once they're inside the house, they may have to break through walls. And we are, as far as I know, the only energy storage company for residential applications that allows you to shut down that de-energize those cables outside of the basically the backup AC outputs. And the reason that's important is if, in other NEC 2017 compliant systems, those firefighters might think, okay, I hit the rapid shutdown, I can go through this wall, but other inverters won't de-energize. So that means that firefighter could still be at risk going through the wall. Whereas if you install this optional rapid shutdown inverter, it's not inverter cable. It's not required by code, but it will protect firefighters from that sort of misunderstanding in the code. And I think personally, I think that this would be a better requirement than all of these module level rooftop devices, but I don't write the code. So letter E, this is the controlled conductor. So this is the conductor that's de-energized below 30 volts in 30 seconds, or in Canada, 30 volts in 10 seconds, which the charge controller will de-energize that in less than 10 seconds. The FLEXmax 100 AFCI does it in less than 1 second, actually. So that's one nice thing, is that this is compliant in Canada, unlike some other products that are somewhere in that 20 to 30 second range, and those are technically not compliant in Canada because they stuck with the 10-second rule on the controlled conductor. Letter F, this is the PV disconnect inside of the load center. G is the battery disconnect, the battery breakers. H is the power supply. So this is the power supply to the rapid shutdown initiator switch, so that this can send a signal up to the devices on the roof. And there are a couple other configurations for this, but those are detailed in our NEC 2017 presentation. I, rapid shutdown control. So this is the rapid shutdown signal from the rapid shutdown initiator to the charge controller. So this is when you throw that switch. This signal will tell the charge controller to shut down, thereby de-energizing the controlled conductor up to the roof and most importantly, bleeding down the capacitors inside of the charge controller so that this line doesn't have any remaining voltage on it. Controlled conductor. So I'll have two more questions here. Controlled conductor is just regulatory terminology for the conductor controlled by the rapid shutdown. So it's specific to the rapid shutdown requirement, and it means that it is the conductor that's controlled by the rapid shutdown initiator. At least that's my understanding. If anybody on the call, has a different understanding, feel free to pipe up. But I believe that it's just regulatory terminology for the conductor that needs to be de-energized in a rapid shutdown event. Another question here. Is it also safe for marine environments? Absolutely. I think that's one of the big benefits of this charge controller is and why it's been very popular in the Caribbean, is because it is fully sealed. So there is no air getting in or out of the charge controller itself. The heat sink is external to the charge controller, as is the fan. So the fan blows air along the heat sink, thereby removing heat from the circuit boards inside the charge controller. So there is no air that gets in or out of the charge controller. So salt should have, essentially no effect on the charge controller itself. Especially with this plastic, you won't even get the corrosion and the rusting that you do with like lower cost folded sheet metal that oftentimes can corrode and be a pretty serious eyesore on lower cost products that start to corrode in salty environments. And yes, other rapid shutdown options are available. This is not the only configuration, but it's a good one. Okay, so this is one of the important slides, and we'll take a close look at this. So on the left side, this is the main wiring difference. On the left side, and this is taken off of the quick start guide for each product. So the left is the quick start guide that ships with the product for the current generation charge controller. On the right, this is the quick start guide. So when your customer or your installer opens this up, or when you open this up, right, and you pull this out of the box, you'll get a piece of paper in full color print with all of this information on it. On the left, you'll notice what is sort of been the standard for OutBack over the years is this common negative bus, and it's a complex concept, but essentially all of the negative for the PV and the batteries runs on the same bus, and the system is able to operate in that, under that condition, where you can see that the PV comes in here, lands here, and then both the battery and the PV conductors go straight from this bus bar with the shunt up to the charge controller. And this is similar on FM80s and FM60s. On the new charge controller, we no longer want to do that, and there's a good reason for that. Essentially, this black symbol here, this represents the Rogowski coil. So it's actually like a donut-shaped plastic coil that goes inside of the wiring compartment. And this is your arc fault detection device. So this is the coil that's sensing arc faults And if it senses one, it sends it to the little control board here, which indicates to the charge controller to shut, there's an arc fault, shut down before a fire starts, right? That's the goal of 1699B, UL 1699B. You'll notice the negative in this quick start guide skips right by that negative bus, goes straight through the Rogowski coil, the sensor coil, into the sensor coil is probably an easy way to remember this. Rogowski is just the guy that invented this particular type of coil, but sensor coil is what it's doing. PV negative goes right through it into the charge controller terminal. Positive does the exact same thing, so no change to the positive. So really, this yellow box highlights the only change, which is that this negative bus no longer contains the PV negative. It's only the battery negative. And we still want to use the shunt because that allows the system monitor to look at the current going in and out of the batteries. So we still want to monitor our battery state of charge and current discharge and all of that and voltage with this shunt, but we no longer need the PV through there. And the reason is, the reason not to, so there's a question here, let's see, can you still bond the PV negative on the battery? Basically, yes, if we did not require arc fault, yes. If you're in a situation where you don't need arc fault, say it's like a ground mount system, or pretty much just a ground mount system where, you're not required to install arc fault and you're not worried about, it's just a metal structure, so you're not worried about an arc fault occurring. And you want to bypass this, right? You just leave the coil out. You basically don't pass the PV conductors through there. And then sure, yes, you could absolutely bond the PV negative like you did on the old one. The reason that we don't bond the PV negative when we are using the arc fault solution, which is the main feature addition for this product, is that PV negative introduces a source of noise. So one thing that's plagued the solar industry for the last few years is false arc fault trips, right? When you're installing these new arc fault solutions that are compliant with really stringent arc fault requirements, they are signaling false arc fault events, and that's because of noise, basically loads or environmental conditions that are introducing electromagnetic noise onto these conductors. So they're putting things like table saws or nearby radios, high quality stereos, inductive loads, all sorts of different things that can introduce electrical signals that when laid over the top of a DC, current flow, they might look like, to an arc fault sensor, they might look like an arc fault event. And what will happen is it'll shut down the system. And according to regulations, you're not allowed to remotely reset an arc fault. Somebody has to go out there and inspect the system and check to see if there is no arc fault before restarting it. And oftentimes, even after restarting it, that same condition will occur, whether it's a noisy load or some sort of environmental condition. And that arc fault event, that false arc fault trip, will happen again and again. And it can be very expensive because it causes downtime for the system. It can cause a significant amount of downtime and revenue loss. So the reason not to bond that negative is this battery negative is going to, basically that introduces a little bit of extra noise. So anything we can do to eliminate noise from the negative, make sure that this sensor is only going to sense arc fault, it's not going to sense anything else. And we've had a lot of success with this in all of our, I think we've had about 100 units operating now for quite some time, tens of thousands of hours of operational, and we haven't had any false arc fault trips, false arc fault events, and all sorts of different testing circumstances. So when installed properly with the positive and the negative not being bonded to any commons, and then they cross over through this arc fault sensor coil, our dual algorithm arc fault solution built into here is very accurate. It's looking for arc fault signatures and nothing else. So we've had a very good success rate on detecting arcs. We passed the UL, the most stringent UL requirements this summer, and we haven't had any false arc fault events either. So that hopefully will keep your system up and running, unlike some of the older, less advanced arc fault solutions on the market. But this is the important piece, is making sure not to bond. If you're in the habit of bonding, like we have typically on OutBack systems in the past, it's an important habit to break when using the arc fault solution in this charge controller. So here's a wiring diagram. Hopefully this isn't too difficult to see, but this is the same. We're looking at the same thing. We're just kind of zooming in on the load center here. So we have this is the current generation, or the first generation that we're phasing out now, where this is the load center. So you have your PV input positives. On the new load center, this has actually changed. So now these are all the same. The generator, grid, and AC, and the neutral are all the same, but these positive PV positives are no longer or these bus bars are no longer PV positives. They're actually PV negatives now. So you can see, if you could, it's kind of hard to see there, but it says 2 charge controller 1, 2 PV 1, negative, negative, 2 charge controller 2, 2 PV 2, negative, negative. And so in pre-wired systems, these will come pre-wired to the charge controller, and all you have to do is bring in your PV negatives 1 and 2 into the load center and land them on these bus bars, and then that will transfer the energy, the current, to the charge controllers. In just the load centers, in the pre-wired load centers that aren't part of a system, these will come with pigtails, which is a new thing for OutBack, but they'll come with pigtails that are appropriately sized for charge controllers mounted on the wall adjacent to the inverter. And of course, you can remove those pigtails and replace them with your own cable if you'd like, but there will be pigtails there to allow you to bring the PV directly into that bus bar and have it transfer up to the charge controller. We see the PV positive still comes into these breakers, and then from these breakers to the charge controllers itself, or as well. So we're repurposing these bus bars to ensure that negative is not common, bonded in with the negative common system. And we have another question, which is, would removing the PV negative from the common negative in all OutBack systems, not just in the FM100 AFCI, be a good idea to reduce harmonics? Well, it's an interesting theory, but I think really we're only looking at, by removing that PV, we're only reducing the harmonics on the PV negative itself. So the charge controller itself doesn't really have a problem with a little bit of electromagnetic noise. Usually, the things that are going to have difficulty with electromagnetic noise are going to be loads interfering with each other. If there's some unusual loads all in the same panel or something like that. But so I don't know that would necessarily. Yeah, maybe in mobile applications. It's a theory. I can't say for sure, but it may be worth trying. But definitely with the arc fault sensor coil, it will, essentially eliminate, as far as our test, our tens of thousands of hours of testing go. By doing this, you'll eliminate the possibility of false arc fault tripping, which is a really, can be a very expensive and time-consuming and frustrating problem. So we'll quickly go through the integrated systems. Unless anybody has any questions on these two wiring diagrams, I'll jump right in. So these are the new load center. So the load center model numbers actually are not changing. So you'll, just when you order new load centers, they'll come with this new wiring configuration. They're not fully released yet, but they will be around the same time that the charge controller goes to general availability. But the part numbers will not change. The new FLEXpower systems, these are, they basically come with an AFCI at the end. This one is, we had to fit it into our part number length, but that A stands for AFCI and LT stands for light. This is a request, especially out of the Caribbean, where we have a single charge controller on an 8 kilowatt inverter. So this is a FLEXpower Radiant 8 kilowatt with a single charge controller. So of course it comes at a lower cost, and you can still fit 7,000 watts of PV on there. So when it's sunny every day of the year, this system may just work for you. And then these are the new system edges. These are not fully released yet either, but they will be on the next price list, and they're very similar to the current system edges. The one thing that's missing off here is our new Blue Plus battery, which is our new sealed cycling battery. But we have energy management and off-grid and backup options. I believe that's it. So yeah, open up to questions. I know we have just 1 minute left, so let me get a quick poll here before everybody drops off. Do any of your charge controller installations require FCI? I think now that we're approaching 2020, year 2020, I think we'll probably, this number may be going up. In the past, I've always gotten about a 50-50 rate on this poll, but I would appreciate any feedback here in regards to, you know, whether any of your standard charge controller installations are requiring AFCI these days. Look at that. So far, it's 50-50. I wonder if I ask again in 6 months what the answer will be. Okay, here we go. Now we're at 60-40. See, that's and just to wrap this up, we'll be going to general release on December 9th is the general release date. We'll make sure that to send out a recording of this. Feel free to share it with anybody you'd like, and have a great day. I'm going to go ahead and end the webinar. Thanks, everybody.